Today we are going to discuss about computation of middle node of the linked list in LeetCode using Java. The problem statement given in LeetCode goes something like this. We have a linked list whose head pointer is given and required to return the middle node of the linked list. Now if there are two middle nodes, return the second node. This is a case where we have odd number of elements and even number of elements in the linked list. In the example here, we have 5 elements as you see here, an odd number of elements, and the middle node is here 3. So the expectation is to return the linked list beginning from the middle of the linked list. The example number 2, or test case 2, we have 6 elements, and so the middle node will be a node after half of the size of the linked list. So here when we have 6 elements, the expectation will be to return an object or a pointer pointing to the middle node exactly by half the size and an element more than that. The goal here will be to find the middle node of the linked list. Consider a use case here. We have a linked list with 5 elements or 5 nodes. The first node at 1. The head points towards the first node. Our algorithm goes something like this. We'll have 2 pointers to begin with, initialized at head pointer of the linked list. We call it as hare and tortoise. Essentially, it is fast and slow pointers, which means they walk at 2 different paces. The slow pointer takes 1 step at a time, and the fast pointer takes 2 steps at a time, traversing through the linked list until the fast pointer hits end of linked list. We see that in action. Now, during the first iteration, we will have tortoise land at second node, that's at 2, and hare at the third one, which is at 3. We continue the iteration because we have not yet hit the fast pointer or hare towards the end of the linked list. The next iteration, we again take the same pace with tortoise landing at 3 and hare landing at the end of the linked list. We have the slow pointer or the tortoise at middle of the linked list pointing at 3 and the fast pointer or hare at end of the linked list. If we were to take one more iteration, then we would land hare at a pointer which does not exist. So we end our loop here and bring up tortoise, which is towards the middle of the linked list. To find the middle node of the linked list, we will have 2 objects. One is slow and the other one is fast. Slow takes 1 step at a time, whereas the fast object would take 2 steps. And we traverse through the linked list. So to begin with, we will declare 2 objects and initialize them. Initialize the fast and slow objects. So we make them essentially point to the head of the linked list. Okay, the next step will be to traverse through the linked list until the fast pointer hits null. So move the slow and fast objects at different pace and traverse through the linked list until first hits end of the list. Okay, so total fast object is not equal to null and fast dot next not equal to null. We keep traversing. So when fast hits null, it means it's end of list. Or when fast dot next is hitting null, it also means we are at end of list, but just one more node to be traversing. But we won't be able to traverse through because we are going to hit the reference object as next to next here. So we traverse until last list or last but one of the linked list. And when we hit at that point, we are at position where the slow pointer will be at the middle of the linked list. So slow pointer or object is now at middle of the linked list. We return slow. We'll go ahead and run this. So we have 5 elements here and the middle is 3. In test case 2 we have 6 elements. We'll see if it successfully be able to identify the middle node in case of both linked list with odd number of elements and even number of elements. Yeah, you're able to figure out. So slow is at 3. Here, slow is at 4. You have been so far hearing from Vidya at colearnables.ai. If you like the kind of videos that I'm making, consider subscribing and liking. Thanks for watching. See you next time. Until then, bye.